Hello guys, welcome to my channel. This is the sixth tutorial in the series of tutorials on Arduino. In this tutorial, we're going to learn about the ultrasonic sensor. So we'll be making a simple distance measurement device using the ultrasonic sensor. So let's quickly see what is on the board. So HCSR04 is the module which we'll be using. It has got 4 pins: VCC, ground, trigger and echo. Trigger pin, okay. When we'll be having a 10 microseconds pulse on the trigger pin, after that the transmitter output, this transmitter antenna will transmit 8 pulses at 40 kHz. Then they will be received by the receiver after reflecting back from any object which comes in front of this sensor module. Then the echo pin will generate a pulse with a width proportional to the distance between the object and the sensor. So this is what I was talking about. This is the transmitter, this is the receiver. It will transmit the pulses. This is the object and this pulse will be reflected back to the receiver. So the time, this time is the pulse duration which will be multiplied by the speed of sound in air and will be divided by 2 because this distance is nearly doubled. So the connections for the hardware I have made already. So the connections for LCD will be same as in the previous tutorial we did, and the trigger pin and the echo pin will be connected to 8 and 9 respectively. We will also connect a buzzer which will generate a beep sound and it will be connected to the 7th pin. So I have a script opened up here which is called ultrasonic sensor. So in the first line of the code, we have defined the library liquid crystal.h, and then I have set the LCD pins. Then I have connected the buzzer to the 7th pin, trigger pin is connected to 8, and echo pin is connected to 9th pin. The pulse time, I have taken a variable for reading the pulse time. So pulse time is equal to 0, distance is equal to 0. The unsigned long is a type of data type which is used to store large strings of numbers. In the setup function, I have defined this. My LCD is in the 16 column into 2 row. Then pin mode for the buzzer will be output, pin mode for the trigger pin will be output, and the echo pin is obviously the input. This serial begin, I don't have to do it. I'll be clearing the LCD if there is anything printed on it before. Okay, let's see what we have got in the loop function. So we have got in the loop function, okay, firstly I'll have made this trigger pin low for 5 microseconds. Then I made it high for 10 microseconds. Then I made it again low for 5 microseconds. So this 10 microseconds high pulse means that after getting this high pulse, the transmitter antenna will transmit 8 pulses with the 40 kilohertz of frequency. Then this will be received at the echo pin. So the time in milliseconds at the echo pin will be calculated with this function which is called the pulse in function, which calculates for how much duration this echo pin has been set to high. Then the distance will be calculated by the simple formula we know all, like distance is equal to speed into time. So this is the pulse time we have calculated, and this is the speed of sound, and will be divided by 2 because the distance is just doubled. Okay, now for printing the distance into the LCD screen, we will have to use this LCD home function for making the cursor at the home position. Then I will be displaying this string distance. Then I'll set the cursor to the next row, and here I will print the distance which I have calculated over here in the 29th line of the code. Then I'll just print the units. Okay, now I have something interesting in this, which is when the distance is sorry the when the object is between the range of 15 to 20 centimeter, the buzzer will make a beep sound with a delay of 120 microseconds. And if it is less than 15 and greater than 10, means it is between 10 and 15, it will make a sound of buzzing with a delay of 90 seconds, which is faster than the 120 microseconds obviously. And then between 10 to 5, it will have the delay of 50 microseconds, and below 5 it will have the delay 10 microseconds. So we will see what is this program going to do when we will execute it. So let's just upload the program. So I'll just hit the upload because I have connected my board into it. My sketch is compiling right now. Okay, so my code is uploaded. Here I can see the distance is 22 centimeter, and I am getting this distance is 22 centimeter. As I take it forward, and when it will be 20 to 15, the buzzer will start buzzing. So now it is 20, so buzzer has started buzzing, beeping, sorry. And now it is 15, it is beeping even faster. Now it is 10, the beep is more faster. And now it is 5 centimeter, and below 5 centimeter it will make this sound only. So that's all for this tutorial. I hope you like it. You may subscribe to my channel if you haven't already. See you in the next tutorial.